Yesterday we looked at the quadratic formula, and we're going to use quadratic formula to help us look at something called nature of the roots. And nature of the roots actually relates to something called the discriminant. So take out your workbook, please, and go to page 340. And we're going to talk about nature of the roots using quadratic formula. And then we are going to summarize some things and get you to do some problems. So if we look at this first equation, it says x squared minus 6x plus 5. So what we're going to do is we're going to take the a, b, and c values and we're going to plug them into our quadratic formula, and we're going to see what we get for solutions. So they've kind of started things here. They've taken the negative of b was negative 6. So now we need negative b squared minus 4 times a times c. So that's going to be negative 6 squared minus 4 times 1 times 5 divided by 2. So if we work out everything inside the brackets, you're going to get 36 minus 20. So this is going to give us a square root of 16. Well, the square root of 16 is 4. So this really is 6 plus 4 and 6 minus 4 divided by 2. Well, 6 plus 4 is 10, and 10 divided by 2 is 5. 6 minus 4 is 2, and 2 divided by 2 is 1. If we confirm that on the graph here, the actual x-intercepts are at 1 and 5. If we look at the second equation, 6x squared minus 6x plus 9, in this case we're going to get negative 6 squared minus 4 times 1 times 9. If you look at what's inside the brackets, underneath the radical, you're going to get 36 minus 36, which is going to give you 0. So what actually ends up happening here is you get 6 plus 0, which is 6 over 3, which is 2. So you actually get two roots that are the same here. You actually have your graph bouncing off or touching the x-axis at 3. That means we have two identical roots of 3 at that location. The last case is 6x squared minus 6x plus 13. So we get negative 6x squared minus 4 times 1 times 13. And what you're going to end up with is you're going to end up with negative 16 under the square root. You've got 36 minus 52, which is going to give us negative 16. Well, you cannot take the square root of a negative number, so we say the roots are not real, or there are no roots. If you look at this graph, there are no x-intercepts, and that's what this is telling us. We can't calculate any x-intercepts, so there aren't any if we actually look at the graph of a parabola. So there's actually three situations we have when you look at the graph of a parabola. You can have two x-intercepts like in the first case. You can have one common x-intercept like the second case, or you can have no x-intercepts like the third case. So what we need to be able to do is we need to be able to determine which one of these three situations actually exists without doing all of this work initially. For example, if we know there are no x-intercepts and we can determine that ahead of time, we don't have to go through and do this whole process. So if we look at the nature of the roots, the discriminant, the three situations are we have roots of quadratic equations which are equal, unequal, or non-real. And it says if you look at the first graph we had on the previous page. So I'm going to just kind of plot this graph here so that we can kind of have these graphs sitting in front of us as we talk about this. But if you look at this first graph, the roots of this equation are real and unequal because the roots of the equation are 5 and 1. They're real numbers, but they're not the same. If you look at the second graph, the roots are real and equal. We had two roots or two x-intercepts that were the same, 3 and 3. And the third graph, the roots were not real. There were no x-intercepts when we have no real roots. So basically what we need to know is what part of the quadratic formula helps us determine this. Well, the discriminant is the part of the quadratic formula that's underneath the radical sign. If we look at the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, this part underneath the radical sign is our discriminant. And if we look at these equations, are the same equations we used when we when we looked at these graphs and found their x-intercepts. So the first equation had roots of 5 and 1, and we said they were real and unequal. And if we look at b squared minus 4ac, well, b squared minus 4ac is this part underneath the radical sign, so it had a value of 16. If we look at the second graph had two x-intercepts that were the same. They were real and equal. And if we look at the discriminant value there, the discriminant was what was under the radical sign. It was 0. And the third case, we had no roots. They were non-real. And we had negative 16 in our discriminant. That was the value underneath the radical sign. So, if we summarize what's in this table, if the discriminant, if b squared minus 4ac is equal to 0, well, that's our second situation here, then the roots are real and equal. So when it's equal to 0, the roots are equal. If it's greater than 0, we have real roots that are unequal. That means we have roots, but they are different. And if it's less than 0, then the roots are non-real, or we have no roots in that particular case. So what you need to remember is if I quickly calculate the discriminant, how do I know if I have roots or I don't have roots? Just by looking at that discriminant value. So let's look at a couple of questions related to that. It says determine the nature of the roots. Anytime they ask you to determine the nature of the roots, they want you to use discriminant. So we're going to use b squared minus 4ac in this particular question. Well, b is negative 1, a is 6, and c is negative 1. So negative 1 squared is 1. Negative 4 times 6 is negative 24, and negative 24 times negative 1 is positive 25. So we get a value that, in this case, this is 24, plus 1 is 25. So this is a value that's greater than 0. And if you have a value that's greater than 0, if we go back to our table or our information, values that are greater than 0 have real roots and they're unequal. So we just say we have real, unequal roots. The next situation, before we can actually figure out the discriminant here, we have to actually rearrange the equation. We have to bring the 8x over to the left-hand side and make this quadratic equal to 0. So we get x squared minus 8x plus 16 equals 0. So in this case, if we use b squared minus 4ac, we get negative 8 squared minus 4 times 1 times 16. Well, negative 8 squared is 64, and this is going to give us negative 64, so we get 0. So if we go back to our table and we look, when we have the discriminant equal to 0, the roots are real and equal. So the roots are real, equal. The last example, if we plug in b, a, and c, we're going to get 4 minus 20, which is negative 16. So that means anytime we have a negative there, we have non-real roots or no roots in that particular case. So knowing when we have equal roots, unequal roots, no roots, that's going to help us solve this next example here. It says determine values for m. So determine values here that give us real distinct roots. Distinct means unequal. real and equal roots or non-real roots. So what we know is that to get real unequal roots is b squared minus 4ac has to be greater than 0. So in this particular question, we know that b is negative 8. We've got minus 4 times a, which in this case a is 1. Now c in this case is m, so we're going to just put m in there. Negative 8 squared is 64. Negative 4 times 1 is negative 4m. So if we solve for m, if we subtract 64 and we divide by negative 4, remember when you divide by negative 4, anytime you divide by a negative, the direction of that sign has to change. So m has to be any value less than 16. If we put any number less than 16 in here, we're going to get real unequal roots. The next situation, b squared minus 4ac has to be equal to 0 if we're going to have real equal roots. So we've got negative 8 squared, remember b is negative 8, minus 4 times 1 times m. That has to be equal to 0. So we get 64 minus 4m equals 0. If we subtract 64 and solve for m by dividing by negative 4, that tells us m has to be exactly 16 if we want to have equal roots. If we want non-real roots, well, without even calculating this, less than 16 is going to give us unequal roots. 16 is going to give us equal roots. Well, anything greater than 16 then is going to give us non-real roots. That's the only reality we haven't looked at in this particular situation. So you should be able to figure out unknown values here using what we know about discriminant and the type of roots that we want. So there we go.